Hey, welcome back. Today we're going to be talking about what is beta decay or beta radiation and how do you solve beta radiation problems. So maybe you're a chemistry or a physical science student. I'm going to talk you through how to do these types of problems really quickly. But first I want to talk briefly about what this thing is. So atoms can be unstable in the nuclei of the atoms. So the atoms themselves can be unstable, meaning under certain circumstances, protons can actually switch into neutrons and neutrons can switch into protons. It happens when the atom is unstable. So when something is unstable, think about something that's about to fall over. We would say is unstable. And in this case, what we mean by being unstable is there's a mismatch between the number of neutrons and protons in the nucleus of an atom. And so the atom becomes unstable, and sometimes you'll get a beta emission or beta radiation problem going on. All right, so what exactly is it? Well, what it is when you have one neutron. So when you have one neutron that undergoes a beta emission, so this is called a beta minus emission, turns into a proton and gives off a high energy electron. That's what we have right here. Here's our high energy electron. Now there's a little more to it. We're not going to worry so much about neutrinos and antineutrinos and the weak nuclear force right now. I'm just teaching you what you need to know if you are a chemistry or a physical science student right now to be able to solve these problems. And one way to think about this is to think about, all right, well, you know what the charge of a neutron is. This is how you can remember this. You know that the charge of a neutron is 0. And this arrow up above can be like an equal sign in terms of a little math problem. And that's like saying +1 plus a -1. And you can see that a law of conservation of charge still is in effect because that is a true mathematical statement. So that's how you can remember this and how you can think about what's going on here. Let's go ahead and apply this to problems and see how this works. Okay, and so here's the problem that we have. Sulfur 32 undergoes beta decay. So the way we're going to write this is sulfur, it's got 16 protons. This one has 32 protons plus neutrons. As a quick reminder, this is our mass number up here. And this is our atomic number, which is the number of protons. And this is the number of protons plus neutrons, or the mass number at the top. So if sulfur undergoes beta decay, then let's think about what happens here. So we've got one neutron over here undergoes a change, and you end up with one more proton plus one electron. So let's think about what would happen here. Well, what would happen in terms of our mass number? Our mass number would actually stay the same because one neutron is one atomic mass units. One atomic mass unit, or AMU, and one proton is as well. One way to think about this is that an electron that has much less mass, we kind of ignore the mass of an electron in this process here. All right, so we know that we're going to have an electron that's going to be given off, and the electron has insignificant mass. We also know the electron has a negative charge, and if we take a look at this, whatever this is has a mass number of 32. But we do know that we have gained one proton. So we've gained one proton. If we have gained one proton, we're no longer talking about sulfur, we're talking about chlorine. So what we have is this equation right here. And what you can do with this is you can also check using the same strategy that I talked about in my previous alpha radiation or alpha decay video that I can put a link to in the upper right about now. But the way you can check is just to do a little mini algebra problem here. And we would say 32 is equal to 32 plus 0. That's a true statement, so we know our top number is correct. Our bottom number over here, the atomic number, the way that we're writing it in this sense. This, let's see if this is a true statement. 16 is equal to 17 minus 1. Is that a true statement? Yes, it is. That checks out. So we know that we've got this problem correct. All right, so that's how you would do one of these problems. Let me show you a second style of problem that you might come up against. But as you can see, these are pretty straightforward. Alright, and this problem says a parent nuclide undergoes beta decay, so we don't know what we're dealing with. It's some question mark, we'll say, undergoes beta decay and forms nickel 28. Actually, let's change the problem. This should probably say 58. Let's use that. And so we know that we have a mass number of 58. We always have an atomic number of 28 for nickel. And we know that there is an electron as a product over here. It has 0 mass comparatively, and it has a -1 charge. So in this case, what we're going to do is use that top and bottom number strategy, like saying little mini algebraic problems to do. We can say an unknown number is equal to 58 plus 0. What's our unknown number? Well, our unknown number for the top is going to be 58. So we can go ahead and write a 58 up here. Okay, very good. And for the bottom number, which is the atomic number written out in the way that we've done this over here, let's do the math. We're going to say some number is equal to 28 minus 1. Well, what's that equal to? Well, that some number, that bottom number, is going to be equal to 27. So we know that our bottom number over here is going to be equal to 27. So the question is, what is question mark? So we would say question mark is equal to 58 and an atomic number of 27 down below here. And so that atom turns out to be cobalt, but we could also call it cobalt's 58 if we wanted to. And that's another way of writing this. This number over here is going to be the mass number that's written. So in any case, that's how you can think through one of these problems. I've done a bunch of other lessons on physical science and basically an entire year of physics lessons. So if you want any more help on this, please take a look. And if you have any questions, let me know. Have a great day. Take care.